Hello, and welcome to today's presentation on water supply assessment. My name is Melissa Montgomery, and I am a project engineer here at EWB USA headquarters. And today's presentation is about assessment trips for water supply projects. So welcome, and thank you for attending. Before we get started, I'd just like to go over the EWB USA mission and vision. As you can see here, our vision is a world in which every community has the capacity to sustainably meet their basic human needs. And our mission is stated here: Engineers Without Borders USA builds a better world through engineering projects that empower communities to meet their basic human needs and equip leaders to solve the world's most pressing challenges. So here's just a quick outline of today's presentation. We'll go over the purpose of the presentation, the objectives of the assessment trip, the resources that we have available for EWB USA water supply projects, and then any questions that you might have. The objectives of the assessment trip will be the majority of the time spent today and will include both technical and non-technical needs throughout the assessment phase of the project. And again, this is for water supply projects. So what we really want to do is we want to provide guidance to our chapters and go over the requirements for those chapters that are traveling on an assessment trip for a water supply project. Presentation assumes that this isn't the first time the team has traveled to the community, but it is before the team has completed their alternatives analysis and preliminary design documents. That it can be also the first time that you travel to the community. So as you may know, our water supply projects can take on many different forms, and depending on the direction of your project, you'll have a slightly different needs for your assessment trip. If you look at the model above, it highlights all that is involved in a water supply system. This presentation isn't going to go into the details of each component of a water supply system, but it'll focus more on general considerations that anyone working on a water supply project could relate to. So these models here actually came from a three-part water supply webinar series that your team can view for more technical and specific details on each of these components. And you can find those on our website if you would like to view those to get more detail. But the purpose here is to really stick to more of the general points that relate to water supply, but then also help direct your team to other resources that are available and that will be available for more specific information. So just to quickly go over these two types, there's generally two models of system that I see chapters use. There's the household scale model and then the community scale model. And this kind of outlines the differences between the two. So let's just go over them quickly. On the household scale model above, you can see generally there's the source, which can be a well, a spring, surface water from a river, or rainwater. And then there's manual distribution, and in this model, generally the consumers personally transport the water to their homes. They go to the water source, collect the water, and then bring it back to their homes. And then if there's any treatment, generally it's a point of use treatment, you know, things like boiling, a biosand filter, chlorination, solar disinfection, and the like. And then in this model, generally households have individual storage where water is stored in their homes in containers until they use it. And then the other model that we see is the larger community scale model, and this is has some of the same components, just in a different way. So start with your source, wherever the water is coming from, and then in this model there's a conduction line where the water is basically conveyed from the source to a storage, and this is Sometimes it's by gravity, sometimes it's pumped. It just depends on the system. And then in this model, in the community scale model, you have your treatment, which is done at the community scale instead of at the point of use. And then there's generally a centralized storage tank where water is kept at an elevation, and then where it's distributed through pipes to the consumers, and then they collect that water either from tap stands that are closer to their homes or may come directly into their house with personal taps. So those are the two kinds of models that you'll be looking at if you're working on a water supply treatment. So generally when you're going on an assessment trip for a water supply project, these are kind of very broad objectives of your trip. You should be defining the problem that's been identified by the community itself, and you're wanting to make sure that it's still a self-identified problem that the community has identified. You want to look, investigate alternatives that are being considered to solve that problem. Things you want to look at your site layout. You know, what are the existing water supply systems that they have in place, and how does that relate to the context of the community? Are they close to the households? You know, and basically, generally mapping out the community is a really big objective of your assessment trip. In addition to that, you're also gathering a lot of technical data. You're looking at if the problem that's been identified is water quantity, you know, you're looking at where they're getting their water from, how much water they're getting. If it's a water quality problem, you'll be wanting to do water quality testing. And so you're gathering a lot of technical data on the trip. In addition to that, you want to be aware of any local laws or permits that are going to be required for any of the work that you're planning to do. And that generally is involved in meeting with the local government, asking the community partners, asking your local NGO partners about any kind of laws and requirements or building codes. Another objective of the trip is to gauge the community's capacity to take on the project. You know, what is their technical knowledge? What kind of skills do they have within the community that can help implement the project? What are their organizational capacity? Or, you know, they have an organized water committee. What kind of educational needs are they going to need to be able to operate and maintain the system long into the future? And then finally, a big objective is to come to execute the community agreement, which is the 902. And this is an agreement that outlines the project and the roles and responsibilities and the expectations of the partners involved. So generally speaking, those are the objectives of what you're trying to accomplish. And we'll go into each of these a little bit more. So the first thing you want to do, as I said, is the problem definition. Your team must be able to provide a clear and concise description of the exact problem that the project is intended to solve. And you want to make sure that this is a priority problem of the community and not your team's perception. The thing that I see here a lot of chapters do is that when they try to define the problem, they're too general. You know, the problem shouldn't be the problem is that the community has insufficient access to water. A better description of a problem would be the problem is that although the community has access within 100 meters to shallow wells throughout the community, they dry out during 3 months of the year. The community perception is that the shallow wells have clean water, and in the dry season the community then goes to a nearby river which the community knows is contaminated, and no form of treatment is used on these shallow wells. That's a very clear and descriptive definition of what the exact problem is that you're trying to solve in that community. And that's what we really want to do first when you're in that community and you're going on an assessment. You want to have a good understanding of what the problem is. And I guess I should emphasize here, you want to make sure that this is a priority problem of the communities and not your team's perception. So as an example, I see oftentimes, chapters putting in the reports that we assume that women want to spend less time collecting water, traveling back and forth to collect the water, when in reality, maybe those women really highly value that time spent at the communal water collection point, and it's a big part of their social activity. So you just want to make sure that you're hearing exactly the priorities of the communities and not your chapter's perception. And then the last thing, just you don't want to get tunnel vision with design options based on just your team experience. You want to, make sure you're looking at all of the options and exploring all of the potential solutions and not limiting yourself based on what your specific team experience is. So these are the main types of EWB USA water supply project. You can see them here. You can have a centralized pipe network that can either be gravity fed or pumped, community wells, point of use treatment, or rainwater catchment. It's really important to have an open mind and to consider each of these options for your community. As you're looking at the alternatives, some might be ruled out because of obvious reasons. For example, if the nearest gravity spring is over 30 kilometers away, that's not going to be a viable option for them, but at least you know what that distance is, and you know of it to be able to make that decision and to rule it out. So the other thing to keep in mind is within all of these options, there are all kinds of more detailed decisions that you're going to be making. For instance, I see oftentimes chapters trying to determine whether they should build a new system completely or to try to improve an existing system that the community has in place. Another thing you might want to consider is, do you want to do household, you want to look at clusters, or do you want to do community taps? Another really important thing to think about is what the energy options are for your pump. Does the community have electricity? Is that even an option? And if they do, can they afford the additional electricity costs for an electric pump? Other things you might want to consider as you're looking at is how you want to implement a project. If there's several different smaller projects that you see that can be implemented, how do you want to phase that? What makes most sense to do in that community? So just things to think about, as you're looking, you want to make sure you're investigating all of the options that might be available for that community. So another big objective during your assessment trip is to come up with a site layout. And sometimes I see chapters struggle with this, but generally speaking, you want to return from that assessment trip having a map that shows what the community layout looks like, so that there is some context to what you're trying to do and you have an understanding of how things are laid out. And when you move into design, this will be really helpful. Some of the things that you want to make sure that to include on your site layout plan, if possible, delineating what the community boundary is really important. And then within that, if there are specific property boundaries that would be important to delineate, that would be also a good thing to include if that's possible. Topography is really important to have on a site layout plan, particularly if you are dealing with a gravity system and you want to make sure that your system is gonna work. You want to show water sources, all the water sources that exist, where they get their water source, if it's from a spring, if it's from a river, or wherever it's coming from. That's a good thing to include on your site plan. And then any existing pipelines, tank locations, storage tanks, any households, those are all really good things to include on the map to show relational distances. And then if there's major roads or rivers or, like a community tap or something like that, that's also something that you want to show on this map. One of the things that I recommend to a lot of my chapters to get assistance with this and to really try to engage with the community is to get them to do a community map. So you can go to, the water committee or maybe a women's group or even in the schools. You can have a little focus group and have them draw a community of their map. And it's really interesting to see the things that they highlight that are important to them that they include on those maps. And it gives you some insight into, how they view their community. So, the way that the things that we would include on our map are certainly different than the things that a student would include or maybe a mother of a household would include. So it's really interesting to just get those different perspectives. So this should be a big objective, is to map your community. In addition to the mapping, you're going to be gathering some technical data. Generally the team members will be collecting technical data while you're in the community, but you can also use this as an opportunity to train the community members on how you're collecting this data. So for things like measuring water supply, it's something if you train someone in the community to do, that they can continue to monitor that flow rate and report back to you when your team leaves. So just something to keep in mind. But the main things that you're trying to collect during the assessment trip is the water supply and demand. So you want to have a really, really good understanding of how much water the community is receiving and then how much they're using. So the supply, if they get the water from a spring or a stream, you want to obviously measure that flow rate. One thing to keep in mind for that type of flow is any seasonal fluctuations in that flow. So, the dry season, rainy season, you want to have an understanding of an annual seasonal cycle of what that supply is. For a well, you want to be looking at the recharge rate for that well to get an understanding of how long it takes that well to recharge once the water is pumped out. If you're looking at a rainwater catchment system, potentially, you'll want to be looking at the gathering information about the annual precipitation, monthly precipitation, and then the roof area where the rainwater will be collected. And for any of these, you always want to have an understanding of any variations that happen throughout the year. So that's the supply. On the demand side, this can vary depending on the community and their water supply source, and you can use some guidelines to help check some of the information that you're getting. But you want to be asking community members how much they're using, or sometimes they have specific containers that they use, so you can ask how many containers of those do they use each day. And then as you're looking for the demand, you always want to consider future growth. You want to consider that when you have better access to water in a community, that's going to foster growth in that community. So you want to take into account any future growth within that community, not just what's the community that's there, the population that's there now. Let's see. So we do have some guidance on how to go about estimating the demand. You can see on our website we have some resources available for you to help guide you with that. And you can also use standard guidelines like the World Health Organization. So in addition to the water quantity, generally on assessment trips you're looking at water quality also. So, you want to be looking at any water supply source that they're using, gathering samples and testing it. And we do have some guidelines on our website for water quality testing guidelines and water quality testing kits. So you can find that on our website under resources. But just in general, you want to think about the intended use of the water. Is it going to be potable? Are they using it for drinking? Or are they just going to be using it for washing clothes and bathing? You want to make visual observations about the color and the smell. You want to really be looking at the watershed or the recharge zone assessment. So you want to, if you're looking, at a well or something, you want to know that whole area that's going to be recharging it. You want to be able to gauge the community's capacity to treat that water. Do they know how to do water quality treatment, or do you need more of an automated system? So those are the things that you want to be looking at with regard to water quality during your assessment trip. As I said earlier, in order to develop the site plan, you probably are going to be gathering some survey data. That means looking at topographic maps, bringing survey equipment or GPS equipment to get specific points and elevations, existing buildings, existing water sources, that sort of thing. It's really important to get a lot of measurements of things that are existing so that you know what they look like, basically. And any sketches that you can do, lots of pictures, that always really helps. If you're doing a really large-scale water system that's going to involve, a lot of fall, a lot of pressure in the line, you might want to consider doing a much more detailed survey so that you can really do your design correctly and have all of the elevation information that you need for that system. So keep that in mind if you're doing a large distribution system, it's a long pipeline or something like that. So in addition to survey data, you want to be gathering soil data. This is going to be if you have any kind of foundation, let's say for a water tank, you'll want to know what the soils are surrounding that. And there's a couple of different ways that you can test the soil. You want to be able to identify any excavation challenges that you might have. If you have a lot of clay soils or a lot of rocks in the soil, you want to be aware of that, so you can consider that as you're doing your design. And then you want to make sure that there's always positive drainage and erosion control, so you want to be looking at the soils for that as well. I guess the one tip that I have for this kind of technical data that you're going to be gathering is that if there's any opportunity for your team to practice gathering this information before you go on your trip, that would be extremely helpful, because you want to really make the most of your time when you're in country gathering this data. You don't want to be trying to learn how to use the survey equipment or any of these testing equipment. So any practice that you can do before you leave is highly recommended. Photo documentation, I think I mentioned this earlier, but you want to make sure that you take lots of pictures of any existing infrastructure and anywhere you're proposing to build anything. And then if there are existing structures or components, a water tank, things like that, you want to make sure you take plenty of measurements so you know what that thing looks like, and you can redraw it on a drawing. And other things that you want to think about, if there's existing pipes, you make sure you're getting information about the material of that pipe, the size, and that sort of information. So in addition to the technical data that you're looking at, you want to be looking at the local laws and permits. So in most of the countries where we work, there are existing laws around the water supply system design, construction, and administration. A couple of examples: in Honduras, they have specific design standards for their water systems with water laws, and then in Kenya, if you drill a well in Kenya, you have to have a permit. So these are things that we need to be aware of as you're going on your assessment trip. So you want to get an understanding of what the community leadership structure is. Is there a water board? How are those typically formed in the country? Who owns the water rights and the land where all the facilities will be placed? This is a really important question because this is different in a lot of different countries where we work. And then, what is the process for getting permission to do the work that you want to do? And what are the government restrictions, and what is their role in providing water in that country? So, and you also want to be looking at locally, regionally, and nationally. An example of this in Peru, if you do a water treatment project, there's various levels of government interaction. There's municipal interaction, there's the health department, and then other regional governments that have a role with implementing and enforcing water treatment. So just make sure that you're asking those questions on your assessment trip so you have an idea of what those requirements will be as you move into your design. Community capacity, this is something that you'll want to gauge during your assessment trip. You want to look at their organizational capacity. Have they managed other community projects? Or do they have the organization to be able to operate and maintain the system that you're planning to implement? What is their financial capacity? Can they afford the 5% cash contribution and 100% of the operation and maintenance costs of the system? And then you want to look at their technical capacity. You want to know if anyone, do they have the understanding to be able to operate and maintain a pump? Do they know, who to contact if there's a problem? Do they know where to get replacement materials? That sort of information. And related to that, one of the things that you want to do on the assessment trip is to assess the availability of materials. As you know, EWB USA requires that all of the materials be available in country, locally, and no materials can be brought from the United States. So you want to spend some time during that assessment trip visiting the local hardware stores, looking at material availability, looking at the cost of those materials so that when you try to come up with your operation and maintenance plan, you'll know how much it's actually going to cost to replace a valve or a pump or whatever component is in your system. So this is another thing that you want to make sure that you cover during your assessment trip. Related to that, you want to be looking at what kind of educational needs will be required with this project. Obviously, when you go to implement the project, you will be providing an operation and maintenance manual, which is a manual that describes how to properly operate the system that you're implementing, how to maintain the system that you're implementing, if there's any training, things that they should be checking on. All of that information should be included in the operation and maintenance manual that you'll be providing to the community members after you complete your work. That is a big component of the educational needs. And again, as you're preparing that, or as you start to think about preparing that on your first assessment trips, you want to think about the target audience. You want to make sure it's hands-on. You want to assess if who's going to be maintaining the system. Do they need more visuals, or can you do text? What's the best method of trying to convey how to operate and maintain the system? In addition to the operation and maintenance, there are opportunities throughout every phase of your project to incorporate education. And just some of the other, we have another presentation available that's simply focused on developing educational materials for your project and your program. But here's just an overview of that. But if you are interested, you should check that out on our website. But other opportunities for educational needs are data collection methods, as I mentioned earlier, getting them to measure water supply, maybe on a monthly basis to get an idea of the seasonal variations, hand washing and hygiene, are always appropriate in a water supply project. How to handle water in the home, how to properly store it, how to conserve water. These are all items and opportunities for your chapter to promote education for your project. And then finally, one big objective of the assessment trip is to come to a project partnership agreement with your community partners. And this is done with the 902 document. And this document really is intended to summarize the roles, responsibilities, and expectations of the partnerships, of the stakeholders in the partnership. It's a pretty standard document, the 902, and usually this is signed during the first or second assessment trip before a chapter moves into the design. And then before a chapter actually implements the project, we also have the 903 document. So we'll go over both of those. So the first is the 902. This document again states the intentions of the partnership and the project. It will specify commitments made with data collection. It can set specific expectations for the communication while the team is in the United States. And then it outlines the community cash contribution as a percentage. And this is signed by each of the project partners, the chapter, the CBO, and the local NGO. And then as you move into the implementation, we have the 903, and this document talks more and gets into more detail about the actual implementation. So it will specify the cash contribution, the roles and responsibilities during the implementation, the construction, and who will be responsible for what, the O&M responsibilities, and the long-term operation and maintenance fees. So all of that is outlined in the 903. We actually have additional information about these two agreements. We have two standards agreements that you can find on our website, and we also have a couple of really short, like 3-minute videos that kind of summarizes these two documents. So if you're interested and want more information, you can find those on our website. And just to summarize, we're nearly done. These are some resources that we have available on our website for our chapters and our members. First, we have some technical webinars or presentations you can find on our website. We have one assessing for sustainability, and then we have a technical 3-part water supply webinar that you can view for additional technical information. We also have some documents that you can look at under our resources. We have a lot of resources on our website. Here you can find things that I talked about during this presentation: a water testing guidance sheet, estimating average daily demand guidance sheet, guidelines for water resources, electrical requirements for pump projects, biosand filter guidelines, design checklist for rainwater catchment projects, a design checklist for a drilled well project, some example documents, and then the 505 site assessment checklist. And so there's just a wealth of information on our website. We do continually update these resources, and we also have a water standing content committee that also develops resources for our members. So if you have any questions as you're looking through the resources, or just specific questions about your project, we ask that you reach out to your EWB USA project engineer. There's 4 of us here at the headquarters. I am Melissa Montgomery at the bottom there, but there is also Joshua Knight, Katrina Myers, and Chris Brandewie. So hopefully you know who your project engineer is here at headquarters. So if you have a specific question, please reach out to them. The emails are listed here. Otherwise, if you have a general question, you can also reach out to me and I can try to help you, or you can email projects@ewb-usa.org. And that's all that I have for today. So I thank you for your time. And if you have any questions, please feel free to reach out to me. Thank you so much. Have a good day.